Hello, everyone. My name is Uriel Martinez, and I have been assigned the Permian period after the Carboniferous and before the always exciting Triassic period. The Permian period was the last period of the Paleozoic era. It began at 298.9 million years ago and ended at about 252.2 million years ago. The world at that time was dominated by a supercontinent, Pangaea, and you can see it here in a bit of a C shape, which had formed due to the collision of Euramerica and Gondwana during the Carboniferous. Pangaea was surrounded by the superocean Panthalassa. The Carboniferous rainforest collapse left behind vast regions of desert within the continental interior. Long before dinosaurs roamed the earth, humid swamp forests, giant insects, and amphibious megafauna ruled the landscape. I would say that the Permian period is most notable for its extensive change in climate that wiped out almost everything. The Permian period derives its name from the Russian region of Perm, where rocks deposited during this time are particularly well developed and studied still to this day. I would actually say that the Permian period had three major climates. At the beginning of the period, glaciation was widespread. However, climate warmed and for a long time actually was generally warmer, humid, and even moist. At the time, as time went on, temperatures continued to rise. Conditions became so hot and dry that this, along with an increase in volcanic activity and other factors, huge crisis arose. This crisis would become the greatest mass extinction episode in Earth's history. It is estimated that no extinction since has killed so much life on the planet. Some 95% of marine species and 70% of land species were wiped out, from corals to synapsids. The highest estimated temperature of ocean surface waters was about 77 to 82 degrees Fahrenheit. It's thought that a population explosion of methane-producing microbes might have also played a large role in the sudden increase of atmospheric methane that also resulted in warming temperatures, ocean acidification, and other changes to the carbon cycle. Some of the more prominent species to have gone extinct during this period include the Arthropleura. Excuse me if I butchered that. I mentioned the Permian period was the age of insects, and while this creature isn't quite an insect, I think it tops the list of the most heebie-jeebie-inducing critters of this time. The Arthropleura was a giant centipede-like arthropod and the largest known land arthropods ever. It was likely omnivorous and venomous as well. Synapsids, along with sauropsids, are the ancestors of reptiles, including dinosaurs and birds. In the early Permian, it appeared that synapsids were to be the dominant group of land animals. This group, you can see, was highly diversified. Finally, pteropsids. These lovely creatures were the stock that gave rise to mammals. Pteropsids first appeared in the Permian period, during which they flourished and evolved into a number of mammal forms, as also another dominant large land animal in the middle Permian into the early Triassic. In the aftermath of the Permian Triassic extinction event, pteropsids did decline in relative importance to the rapidly diversifying reptiles during the middle Triassic. On land, giant swamp forests and Carboniferous began to dry out. The mossy plants that depended on spores for reproduction were being replaced by the first seed-bearing plants, gymnosperms. Gymnosperms are vascular plants able to transport water internally. They have exposed seeds that develop on the scales of cones. Also ferns, although they first appeared more than 360 million years ago, many of the families or species that we know today actually didn't appear until 145 million years ago, so very different from what we have today. These ferns reproduce via spores and have neither seeds nor flowers. They differ from mosses and other bryophytes by being vascular, or rather having specialized tissues that conduct water and nutrients, and having life cycles in which the branched sporophyte is the dominant phase. And in the end, although almost unrecognizable today and almost fully destroyed by climate change, during these estimated 47 million years, I really do believe that the groundwork was being laid for the future of life on Earth. Thank you.